Welcome to The Explainer. Today we're decoding the real-world magic behind a concept called elasticity of demand, and we're going to master the mathematical fundamentals of it together. Now, I know textbook economics can sometimes feel like this giant maze of graphs and equations, but honestly, don't sweat it. We're starting from absolute zero today. By the end of this, you're going to see exactly how these concepts govern literally everything we buy.
Let's kick things off with a little thought experiment. I want you to picture your absolute favorite snack in the world. Got it in your head? Okay, now imagine you walk into the store tomorrow, and the price has suddenly doubled. No warning, just bam, twice as expensive. Would you still buy it, or would you immediately drop it and look for something cheaper? Aisa kyun hota hai? Why exactly does this happen? Why do we stubbornly keep buying some things even when they get outrageously expensive, while we instantly abandon other products over a tiny little price hike?
Well, it really all comes down to how our demand stretches. Think of it kind of like a rubber band. For luxuries, say a brand new sports car or a high-end designer watch, our demand stretches super easily, just like that rubber band. If the price jumps up, our desire to buy it snaps back fast, and we just walk away. No big deal. But for necessities, things like life-saving medicine or basic food staples, our demand is more like a thick, stiff rope. It barely moves at all. No matter how much the price changes, we still have to buy it because, well, our lives depend on it.
And this brings us to our formal definition for today: price elasticity of demand. The textbook defines this as the responsiveness of the quantity demanded of a commodity to a change in its price. Now, I know that sounds highly technical, but honestly, elasticity is really just a fancy economic term for measuring kitna asar padta hai, how much impact a price change actually has on us, the buyers. If a price change causes a massive drop in sales, boom, the demand is elastic. If the sales barely budge, the demand is inelastic.
Section 1. What changes our demand?
So, let's explore the hidden forces operating behind the scenes. Economists call these determinants. They're the factors that decide whether our demand behaves like that stretchy rubber band or that stubborn, stiff rope. Now, a dense textbook table of these determinants might feel a bit overwhelming at first glance, but what's really fascinating here is how it beautifully maps out everyday human psychology. It details all these different conditions, like how many substitutes are available, or how many different uses a product has, that fundamentally alter how we react to price tags.
But hey, we don't need to memorize a whole list. Let's just distill it down to 3 absolutely crucial takeaways. Number 1, the nature of the commodity itself. Is it a basic necessity or a luxury? Number 2, habits. And number 3, the time period. Let's zoom in on habits for a second. If you are deeply habituated to your morning cup of tea, your demand is relatively inelastic. Even if the government heavily taxes tea leaves and the price skyrockets, you're probably still going to buy it, right? Because your brain demands that morning chai. The habit completely overrides the price change.
And that leaves us perfectly into a concept we can call zarurat versus aram, which basically means necessity versus luxury, specifically when we're talking about the postponement of consumption. Just ask yourself, can I delay buying this? If you can easily postpone buying something, like say a massive new television for your aram, your comfort, your demand is relatively elastic. You'll just wait for the holiday sales. But if it's a zarurat, something totally impossible to postpone, like an emergency surgery, your demand is highly inelastic. You pay whatever is asked right then and there.
Section 2. Measuring elasticity, the formula.
Okay, so we understand the psychology now, but how do economists actually put a hard number on this? How do we measure it? Well, to measure elasticity at a specific price point on a straight demand curve, we use something called the point method. And I promise you, even if math isn't exactly your favorite subject, we are going to solve this together like a really simple logical puzzle. The formula is actually incredibly elegant. You just take the lower segment of the demand curve and divide it by the upper segment. That's literally it. That's the whole shebang. Lower divided by upper.
Let's visualize this step by step to make it crystal clear. Imagine a straight line angling downward on a graph. This is our linear demand curve. We'll call it line AB. Now, for our example, let's say this line is exactly 8 centimeters long. Step 1. You pick a specific point on that line where you want to figure out the elasticity. Step 2. You measure the distance from your point all the way down to the bottom x-axis. That right there is your lower segment. Step 3. You measure the distance from your point all the way up to the top y-axis, and that is your upper segment.
Now let's see what happens when the result is exactly 1. This magical number happens right at the exact mathematical middle of our demand curve. We'll go ahead and call this center spot point P.
So let's look at how the basic math shakes out here. We're at point P exactly in the middle of our 8 centimeter line. That means our lower segment, from point P down to B, is exactly 4 centimeters. And our upper segment, from point P up to A, is also 4 centimeters. When we apply our super simple formula, lower divided by upper, we do 4 divided by 4, which gives us exactly 1. Economists call this unitary elastic. It essentially means the percentage change in price perfectly matches the percentage change in demand. Barabar asar, equal impact.
All right, let's see how this builds. What happens if we slide down that same line to a brand new spot? Let's pick point P1, which sits much lower on the demand curve, way closer to the bottom axis. Suddenly, our elasticity drops all the way down to 0.33. Let's figure out why.
This brilliantly illustrates the math in action. Down at point P1, we are low on the line, so the bottom piece, the lower segment P1B, is very short, just 2 centimeters. But the upper segment P1A, stretching all the way back up to the top, is much longer, 6 centimeters. So our formula becomes 2 divided by 6, which equals 0.33. Because this result is less than 1, it proves to us mathematically that the demand right here is relatively inelastic. Buyers at this lower price point are just way less responsive to price changes.
Section 3. Why this matters today.
Now, you might be asking yourself, okay, why do we actually care about dividing an 8 centimeter line? Well, in the real world, massive businesses use these exact point method concepts to set the prices you and I pay every single day. Before a company raises the price of your favorite streaming service or your preferred brand of coffee, they calculate this elasticity. If they know they're at an inelastic point, they know they can safely raise prices without losing you. So, I'll leave you with this to think about. Look around your room right now, pick 3 items you own. Is your personal demand for those specific items elastic or inelastic? If their prices literally doubled tomorrow, which items would you completely stop buying and which ones would you just grit your teeth and buy anyway? Figuring that out doesn't just teach you economics, it reveals exactly how you operate as a consumer. Thanks so much for learning with me today, and keep questioning the world around you.